let's see the paths of BIU and EU. Now, this is the whole architecture of 8085. Okay, now coming to the first one is BIU, bus interface unit. So here in the bus interface unit, you have a small queue structure here. It's called instruction queue. Why instruction queue? Because this is used only to store instructions. Okay, so now what you do, you do a small calculation here. This is the physical address calculation. That is why a summation symbol is put here. So some addition have to take place. Okay, I will tell you what it is. So that addition takes place, address is calculated, memory address is calculated in this block. Then whichever address is pointed to, it goes to that address location in the memory, okay, fetches that particular instruction, brings the instruction and loads it into the queue. So the first instruction that is loaded will go into the first position. The second instruction that is loaded will go into the second position and so on. And once you need to execute the instruction, because this is having a queue position, the first in instruction will be coming out first. So first instruction will come out first. And it will move on to the EU unit, which is the execution unit. In execution unit, first the instruction will move to the instruction decoder, where it will be decoded and it will be understood as of what instruction it is. Okay, once you understand what instruction it is, that information will be given to the control unit. Control unit only will have to generate the control signal. Add means add signal, subtract means subtract signal. Okay, logical operation means logical operation signal has to be generated by the control signal. Now, the same information about the instruction, that is, when you decode it, parallelly the information also will be going to ALU. So in arithmetic and logic unit, the data has to be given for the, suppose it is addition, the two data has to be fetched. So it has to be fetched from the memory, okay, and the data has to be given here. Then arithmetic operation takes place. Depending on the arithmetic operation, the flags change. Flags in the sense carry flag, parity flag, okay, zero flag, same like what we saw in 8085. Here there are some extra flags. I'll tell you what it is. Okay, the flags change depending on the operation that happens in the ALU. Then the final result of the output will be coming out. Okay, and this black color is nothing but buses. So through the bus it will be taken out, and either it will be stored in one of the registers, or it will go back and it will be stored in the memory, or it will go back to some IO device that is connected to your microprocessor. This is what happens inside your CPU for instruction execution. This is clear, ma? No response from anybody? Hello?
Yes, ma'am.
Yes, ma'am.
Were you listening to me or I was talking to myself?
Listening.
Okay.
Listening.
My own doubts, Jabez. Yeah. Coming to the registers, okay, the different types of registers that are available in 8086 is these are the registers. The main register here is called the accumulator. This is a very, very important register, as we saw in 8085. In 8086 also, accumulator plays a very major role. Okay, now this is all registers here mostly are 16-bit. You can see here the register size, mostly all registers are 16-bit. Okay, if you want to operate it as 8-bit, you will have to divide it into half. So A will become AH and AL. L means lower part of A, H means higher part of A. So 16 will be divided into lower 8-bit, higher 8-bit. Okay, then only it can, so like how we do pairing in 8085, here we do separation. Okay, because all registers are by default 16-bit in size. So if you don't want 16-bit register, you want to use it as an 8-bit, divide it into two halves. Lower half will be called as L, upper half will be called as H. Okay, so similarly you have 4 general purpose registers, A, B, C, D. Please take up each and every word from me. General purpose register. There are only 4. Why they are called as general purpose registers? Because they are meant for any general work. storing anything, retrieving anything, data transferring from one location to another location. For all these general purposes or for multi-purposes, these registers are used. If you want to use them as a 16-bit, use them as it is, AX, BX, CX, and DX. But you don't want them to be used as 16-bit, you want to only use it as an 8-bit, divide it into two halves, lower half, upper half. B also lower half, upper half. Okay. The other special function registers, which means registers meant only for a specific function. They are called as special function registers. The first register is called pointer register. So there are two pointer registers. One is called stack pointer, similar to what we saw in 8085, and second is called base pointer. This is something new. Okay, I will tell you what it is. So stack pointer, you know the task, right? It will always point to the what? What is the job of a stack pointer, ma? What is the task of a stack pointer? Hey, come on, don't upset me. What will a stack pointer do?
It will point to the top of stack.
Ah, that's it, very good. Why do you hesitate so much? Okay, good, very good. It points to the top of the stack, or it holds the address of the stack memory, right? Whichever the current that top address will be available in the stack pointer. So that is stack pointer. We have also something called as base pointer and two other index registers called source index and destination index. Now, what about these three registers is they are used to generate different addressing modes. Okay, here we have more types of addressing modes than compared to 8085. So these registers will help you in those addressing modes. I will tell you what it is. Okay, and we have something called a flag register. Nothing but same as condition code registers that we saw in 8085. There in 8085 it was an 8-bit register. Flag register was 8-bit. Out of that only 5 bits we used. Remaining was unused. Carry, okay, overflow, parity, sign, and 0. Only 5 bits, 5 flags we used, right? Remaining 3 bits were unused. Here we have a 16-bit flag register. Let's see how many will be used and how many are unused. Okay, ma? Now, there is also some kind of separate type of registers called as segment registers. Please, can you repeat after me? What are they called as?
Segment register.
Yeah, only one person is responding, poor guy. What about others? Can I hear from some girls? Can you read what are the 4 segments here? Girls, somebody? Shall I mark all girls are absent for today's class?
Ma'am, extra segment, code segment, stack segment, and data segment.
Okay, so there are 4 segment registers, ECSD, extra segment, code segment, stack segment, and data segment. Let's see what are the tasks of these segment registers, maybe in the later. Okay, and in 8085, we had a special register which stores the address of the next instruction. Can you tell me what is the name of that register? Hello? I'm repeating the question once again. We had a register in 8085 which stores the address of the next instruction. Okay, what is that register called as?
Program counter.
Very good. It's called as program counter. Here, do we have something like that here in 8086? By the same name? No, right? Yes or no? Are you able to see that name here in the list of registers?
No, ma'am.
No.
No, ma'am.
So, can you guess which would be acting as a program counter here? It's renamed. Any guesses which would be used as program counter here?
Maybe instruction pointer.
Very good. You're right. 100% right. Okay, so instruction pointer is the renamed register for program counter. Okay, ma? So all registers are how many bit in size?
16.
16. Okay, good. Very good. So coming to the, I think all this I already discussed, so I'm just skipping it. Yeah. Now coming to the flag registers, I told you it's a 16-bit register, but out of it only 9 are used. Remaining all these U's are called U. So 4 U here, there is a U here, U. So these U's are meaning which unused flag. That's why U. Okay. So out of this 16, only 9 flags are being used here. So they are like, carry flag, okay, parity flag, auxiliary carry, zero flag, sign flag, overflow flag, and trap flag. Okay, there are also some extra flags here. So these are the flags. So here you can see, first is the overflow. OF means overflow flag. Then DF means direction flag. So direction flag is mainly used when you work with string instructions. String. Okay, happy birthday. HAPPYBARTHDAY. It's a string. Okay, so when you work with string instructions, this direction flag, if it is 0, that means the string has to be processed from the lowest to the highest. If it is 1, the string has to be processed from the highest to the lowest. Okay, so it should be, suppose the string is happy. Okay, if it is 0, it is from the lowest to highest. So YPPAH, that is the order in which the string will be processed. If the bit is equal to, direction bit is equal to 1, then it will be processed from the highest. So HAPPY. Got it? So that is the use of direction flag. Then we have something called as interrupt flag. You know what's an interrupt, right? In 885, I already told you. So this interrupt flag will help you to recognize external interrupts. Whenever there is an external interrupt from, suppose you're connecting a motor, or you have connected another chip, or you have connected some other audio video device. That device wants to communicate anything to your CPU, it will tell you only through this interrupt flag. So whenever your interrupt flag is enabled, then it will say, okay, some other device wants to communicate with your 8086. Okay, so that is understood by the interrupt flag. Next we have is trap flag. Sorry, there is a spelling mistake here. TRAP, trap. Okay, so this is like, this is a kind of very serious kind of instructions, like suppose your power is down or something wrong, those instructions are given by this trap flag. Okay, then S is nothing but sign flag. So positive or negative, depending on the result. If the sign flag is 0, that means suppose an arithmetic operation has taken place. If your sign flag, says 0, that means the result of that arithmetic operation is positive. Suppose your sign flag is 1, then result of that arithmetic operation is negative. Okay, that is understood. So next is zero flag. Now here also, when you compare two numbers, suppose A, you want to find out A and B, whether they are equal to each other, greater than A is greater than B or A is less than B. So what you do? You subtract A from B. Suppose if both are equal, what should be the result of subtraction?
0.
0. So automatically you have to check your zero flag. If your zero flag is set equal to 1, that means A is equal to B. If your zero flag is not set equal to 1, it's equal to 0, that means A is not equal to 0. Either A will be greater than B or A will be less than B. Now, how do you find out whether A is greater than B or less than B? You'll have to check which flag. See, you're subtracting A from B, ma. You want to find out whether A is greater than B, equal to B or less than B. Yes, ma?
Carry flag.
Is it carry flag or should I check the sign flag?
Oh, yes, ma'am. Sign flag.
Sign flag is much better option, right? If A was greater than B, my sign flag will be 0 or 1. Hey, please, think and tell me. If A is greater than B, A minus B result will end in positive or negative?
Positive.
So automatically my sign flag will be 0. Right? If A minus B results end in negative, that means A is less than B or greater than B?
Less than B.
You understood? So having a combination of 0 flag and sign flag, you will be able to compare any two numbers. That is possible. This is just one example. I'm telling you where these flags can be used to take some decisions. Okay, ma? If the subtraction ends in 0 flag, suppose your 0 flag is made equal to 1, then we can decide both are equal. A is equal to B. Okay. Next is we have something called parity flag. Before that, we also have something called auxiliary carry. Okay. So what is the difference between carry and auxiliary carries? Carry is the end carry. Okay. When you add two numbers, finally you will get a carry, right? End carry. That is called the carry. That is the CF. Auxiliary carry is the carry that you get in between. Okay. Suppose you are adding a 4-digit number. Between the second digit and third digit, you will get a carry, right? That is called auxiliary carry. Are you getting what I'm saying, ma? Yeah.
Yes, ma'am.
Suppose you are adding a 6-digit number. In between also, there is a possibility of getting a carry, right? Between the 4th digit to 5th digit, there will be a carry. Between the 5th and the 6th digit, there will be a carry. So that is called auxiliary carry. Finally, if you get a carry, final addition, after adding all the digits, finally you get a carry. That is called normal carry. So that is the difference between auxiliary carry and ordinary carry. Got it, ma? Auxiliary carry is the in-between carry that happens between the nibbles. Okay, normal carry is the final end carry that you get out of addition. In case of subtraction, the carry itself is called as what? When subtraction happens, borrow. Very good. Carry is called as a borrow. Okay, there is nothing called auxiliary borrow. There's only auxiliary carry and then full carry. Okay, there is nothing called auxiliary borrow. Don't confuse. And last one is called the parity flag. So what is this parity flag is? When you send a number, when you send a data from one location to another location, you want to verify whether the data sent is correct or not, whether a wrong data has been transmitted or something has gone wrong or something. In that case, you attach a parity bit along with it. Okay, for ensuring that your data is transferred properly. Okay, that is for data security or data authentication. That is called the parity flag. Okay, more on this we will be discussing in the later part. Just remember, parity is used for data authentication. Okay, to ensure the data has been transmitted correctly from the sender to the receiver. Okay, ma? You use the parity bit, that is called the parity flag. So how many flags are there in 8086? Totally?
9.
9 flags, but totally the register sizes? What is the flag register size of 8086? 16. So only out of which only 9 is used, the remaining are unused flags. So 1, 2, 3, 4, 5, 6 flags are unused and only 9 is being used. Clear, ma?
Yes,
ma'am. Yes, ma'am.
Good. I think I can stop over here. Memory segmentation, I can touch. If I start now, I won't be able to complete it. Now, just tell me what you understood today in 8086. I will just, I'm not going to go very deep into 8086. Actually, this is a very interesting microprocessor. But I'll be only touching upon memory segmentation, how to do the memory calculation. Okay, and then how to the instruction pointer usage and all that. And then I'll just stop it. Okay, maybe 1 more hour I will use for explaining about 8086. Now, so far, what have you understood about 8086? You have 4 more minutes. Can you just give a